you. What was this, page 316, right, or something? 361. Okay, so the last one, which was that 43? Okay, 43. We'll look at that one first. We have 1/2 x squared plus 2/5 y squared minus 4/3 x squared plus 1/3 y squared plus 5/6 x squared minus 2/3 y squared. Oof. So what we'll want to do is first see if inside the parentheses there's anything we can do to combine like terms together. And what we see is that inside the parentheses they are not like terms, right? We have x squareds and y squareds. We can't combine those. But if we remove the parentheses, then we can start putting stuff together. So I'm going to remove the parentheses. To do that, I look at the number in front of each of the parentheses. So in the first parentheses, there's really a 1 there. In the second one, there's like a -1. The third one, there's like a 1. And then I distribute those through. So the first one, I distribute a 1 through, nothing changes, right? But the parentheses does go, it does go away. So I get exactly what was there. On the second one, when I multiply through, it changes the signs, right? Changes the positive 4/3 x squared to a negative. So we get negative 4/3 x squared, and then a negative 1/3 y squared. And then on the third parentheses, again, nothing changes, right? Okay, so that's what that is. Now we look for like terms here. I have x squared, x squared, x squared. So all three of those can be put together if I can put their coefficients together. So let me highlight or circle, I'll circle the coefficients. I have a 1/2, I have a negative 4/3, and I have a positive 5/6. So I'm going to do that. This is going to be kind of scratch work right here. I'm going to put together 1/2 minus 4/3 plus 5/6. So I'm trying to add three fractions together, so I have to get a common denominator. The common denominator would be 6. So now you say, what do you multiply each of those fractions by, top and bottom, to get 6 on the bottom? So on the first fraction, I multiply 3 on top and bottom. The second fraction, I'll try and squeeze it over here on the right, 2 on top and bottom. And on the last one, do I need to do anything? No. So now multiply these two fractions together. 3/3 times 1/2, you multiply straight across. 3/6 minus what? 8/6 plus 5/6. And now when we put these together, all I have to do is do 3, take away 8, add 5. So what's 3 take away 8, add 5? 0. 3 minus 8 is -5, right? Right? 3 minus 8 is -5, plus 5 is 0. So you get 0/6, which is 0. Do you agree? That means that the coefficient in front of x squared is 0. So if I come back down, I'm trying to continue my answer here. I know right now that those x squareds come together to be 0x squared. But 0 in front of x squared really makes it a 0, doesn't it? So it's just going to go away completely, which is kind of interesting. Now on the y squared terms, I have to look at the coefficients. 2/5 minus 1/3. Computer's acting funny. Minus 2/3. So let me do that scratch work right here. I'm taking 2/5. I'm subtracting 1/3. I'm subtracting 2/3. I have to get a common denominator here, which would be what? 15. So I multiply top and bottom of the first fraction by 3. Second fraction, top and bottom by 5. Third fraction, top and bottom by 5. And then I multiply each of the ones I circled together to get my new fraction. So what should I have? 6 over 15 minus 5 over 15 minus 10 over 15. And then I put the numerators together. 6, take away 5, and then so take away 10. So 6 minus 5 is 1. 1 take away 10, negative 9. So you get negative 9 over 15. That fraction reduces because 3 goes into each of those. Negative 3 over 5. That means that my answer, again, I'm coming down here and putting my answer here. I had 0x squared. I'm going to have minus 3/5 y squared. Man, why is this, doesn't want to cooperate today. And that's just negative 3/5 y squared. That's it. What was the question? You okay? Okay. That help? Okay, and then 29? All right. So moving on here, number 29. We have, it says find the sum of 5x squared minus 8xy plus 5, am I not? Is that it? Oh, 5x squared? Is that not the one? Oh, that's 27. You want me to do 27? Yeah, that's okay. I'll do 27 instead. That has the decimals. Okay, so it says 5.6a to the fourth. Is that the one? Minus 2.1a plus 8.4. It says find the sum of that. So I'll put in parentheses. And sum means add together. 2.9a to the fourth minus 4.8a minus 5.7. You figure it out? Okay. Ah, okay. And then the other problem? Okay. All right. Okay. We're going to proceed. I'm not going to do it. Is that okay? I'm not going to do it. Okay. All right. We're going to proceed. We're going to start the next section. The next section is titled, well, we were just doing addition and subtraction, weren't we? We were taking polynomials, we were adding and subtracting them together, and now we're going to do multiplying polynomials. So that's what 5.4 is. We are on page 364. Multiplying polynomials. Let me do something real quick. 5.4. All right, so when we multiply polynomials, there's a few things we need to remember, all right, about multiplication of polynomials. The first thing are these properties of exponents that we already learned. Remember that we had, I'll say recall, that means we talked about this. Recall that x to the n times x to the m was x to the n plus m. Remember that? If you have the same base, x and x are the bases, and one of them is raised to a power, the other one's raised to a different power, you add the powers together. So we need that today. We need to make sure we remember that. And with that, we can just start doing this multiplication. All right, now, I will remind you also that if we had something like 4x squared, that's how many terms do you see there? One term, right? That's one term. Terms, remember, are separated by addition and subtraction. We call this a monomial. Mono meaning one. If we see something like 4x squared plus x, we call that a binomial. If we see 4x squared plus x minus 4, what do you think? Trinomial? So on and so forth. Now, after try, we stop using the words because it starts, you start to run out of descriptives for things like that. So try. Those are the three I'll be talking about today. So what we're going to do first is we're going to start off multiplying a monomial times a monomial. Then we're going to go monomial times a binomial, and then monomial times a trinomial. Then we're going to do binomial times binomial, binomial times trinomial, and then we're going to do trinomial times trinomial. So yeah, we're just going to start seeing what it's like to have to multiply these things together. So we're going to start here. It's an example of multiplying a monomial times a monomial again. That means a single term times a single term. So what about 5x squared y, and then parentheses, negative 3x to the fourth y squared z. So I want to first point out the monomials. The parentheses separate these. You could look at the 5xy squared as a single term, and then over here is a single term. But they are not separated by addition, right? Or subtraction. They're being multiplied. That's what the parentheses mean. Multiply the two together. So there is an implied multiplication in here. This means multiply. Well, with multiplication, we need to remember that when you multiply two things together, it does not matter what order they're in, right? Do y'all remember that? If I say what's 3 times negative 4, isn't that the same as negative 4 times 3? Yes? We call that the commutative property of multiplication, that order doesn't matter. So what I'm going to do here is first I'm going to try and get rid of the parentheses. So what's the number in front of the first parentheses? 1. If I not distributed 1, but if I multiply 1 through, nothing happens, right? It's the same thing. What's the number in front of the other one? 1 again, right? And so basically I'm going to drop the parentheses. They're just going to go away. But watch what I do. 5 times x squared times y times negative 3 times x to the fourth times y squared times z. All I'm doing is I'm just stressing to you that between each of these factors is multiplication, right? And now what I'm going to do is I'm going to use this property of commuting, and I'm going to move things around. So I'm going to put all my numbers together. I have a 5 and negative 3. I'm going to put those together. I'm going to put my x's together. I'm going to put my y's together and my z's together. So it's going to look like this. This is 5 times negative 3 times x squared times x to the fourth times y squared times z. So that's just rearranging things. And then I start to see what can I multiply together. So how about 5 times negative 3? Negative 15, right? That's right. You had a good Valentine's. That's what's wrong with you. And then I can put x squared and x to the fourth together. What does that become? X is 6. So that property we just said, you add the two together. So x to the sixth. How many y's will we have? Y to the third. So y to the third. And then z, just z. And that's it. You're done. So monomial, it's really just about rearranging things and then multiplying things together. Questions? Okay, now let's try monomial, binomial. Monomial, binomial. So if I write a monomial, 3x squared y, and then in parentheses, a binomial. Binomial will have to have two terms, won't it? Bi meaning two. So what if I put xy minus 3x squared z? Would you agree that what's in the parentheses is a binomial, and what's out in front of it is a monomial? So I'm multiplying a monomial times a binomial. Now the way we would do this is distribution. We distribute just the way we did before. Now, distribution occurs only because we have two terms, right? That minus sign separates two terms inside the parentheses, so that multiplication has to pass through to each of the terms. Now, when I do the first multiplication, let me color code these. The first multiplication is the blue one, right? When I do the blue one, that's a what times a what? Yes, and that's what, but I'm saying is in terms of monomial, binomial, trinomial, oh, my battery time. That's a monomial, right? 3x squared y, and now I'm multiplying it times xy, that's a monomial. So this is really, this blue multiplication is just a monomial times a monomial, which is what we just did, isn't it? But that's just the first part. So this equals I'm going to go a little slower, 3x squared y times xy. I'll do that. I'm going to do this as I move down. But it's that first one times this one, right? Then I have a minus sign. And that's just that right there, right? And now I'm going to do the 3x squared y times 3x squared z. That's a monomial times a monomial again. So it's going to look like this. It'll be 3x squared y times 3x squared z. And now I'll do each of these individually. And this time I'm not going to rearrange. I'm going to try and do it mentally. All right? So on the first one here, I have a 3, right? Don't have any other numbers, so I'll have 3, right? Now let's look at the x's. X squared and x, right? Put those two together. You add the exponents. 2 plus 1 is 3. Right? There's not a 1 there, but we understand there's a 1 there. Okay, and then how many y's would we have? Well, so we say y squared, right? That's the first one. Now let's do the second one. What about a number? So 3 and 3 would be 9. So we have the 9. We have the minus in front of it, right? And then how about x's? X to the 4th, and then y and z, right? We can't do anything else. And that's it. We're done. Well, we're done as long as these two are not like terms. Are these two like terms? No. So we can't put those together. It could turn out that maybe they did, but you'll want to check and just look at them real quick and see, do those combine. So we're done. Is that all right? Now, on the examples I'm showing you right now, I'm going to just show you these without throwing in things like fractions and decimals. And then what will happen is when we practice today, because I'm going to let you do a lot of practicing today, when you get to the practicing, some of the problems might have some fractions. Like imagine that was a 3, and in here was 1/2 xy. Then you'd have to go 3 times a half and figure out what that is. So just realize that you may see that as we progress. All right, so we've done monomial, binomial. Now monomial, trinomial will be our next thing. So everyone see the trinomial in the parentheses? 1, 2, 3 terms, and then outside 1 term. So to do this, there's going to be 3 multiplications. 1, 2, 3. Each one of those multiplications is a monomial and a monomial, right? Okay, so let's try it. Now let's see how much of this we can do without having to rewrite everything. So what is negative 5x squared times x squared? So what are you going to be able to put together here? You'll have negative 5, and then x to the fourth. X to the fourth came from adding the 2 exponents together, right? See if you can do the next one in the blue one. Positive 20, x to what? Third power, right? The last one, positive or negative? Negative 35x squared. Since there's only a 7 here, the 7 and the negative 5 multiply. Other than that, the x squared just comes along for the ride. So negative 35x squared. Is that all right? Okay. Let's stop there. I'm going to pause the video. I'm going to give you 3 problems to do real quick. Or actually, let's just do one of these. I think if you can do one of these, you can probably do all 3, right? So, but I'm gonna add some fractions just for fun for you. Let's see how you do. Okay, here's your example. Try 5/3 x. Let's multiply that times negative 2x squared plus 3x minus 9xy squared. All right, you do that. See how you do on that. That's a monomial trinomial, right? Okay, so the first thing I did is I did my monomial through to the 3 terms in the trinomial. And I just wrote down 5/3 x times, and then whatever was here, negative 2x squared. And I did that for all 3. Then I rearranged things. So I put my 5/3 next to my negative 2. And notice that I changed my negative 2 to a fraction, because I'm about to multiply them. So I wanted them both to be fractions. Then I put my x's together. Over here, 5/3, I put it next to a 3. And again, I wrote my 3 as a 3 over 1. Over here on this one, I did a 5/3 and a negative 9. I put those next to each other, writing negative 9 over 1. Now, on a test, you wouldn't have to show all this detail. I'm just trying to help you see each step. Now, on multiplication of the fractions on the first one, I do 5 times negative 2. That's negative 10. 3 times 1 is 3. So that's negative 10/3. Then my x and x squared becomes x cubed. Over here, I could have just canceled these 3's and been 5. But I decided to go straight across and make it 15 over 3. Then x and x is x squared. The last one, I multiply straight across, negative 45 over 3. And then I put my 2 x's together, get x squared, y squared. The last step is just reducing these fractions. 15 divided by 3 is 5. Negative 45 divided by 3 is negative 15. Okay? All right. Now, we've done monomial, 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 binomial, monomial, trinomial. So now we need to do binomial, bi and tri, but we also need bi and bi, right? So 2 and 2. So what's a binomial times a binomial? This comes up a lot, okay? So I'm going to put a little star next to this one because everyone here needs to get really good at multiplying binomials together. Yes. Let's take something like 3xy plus 4xy squared, and then put that in parentheses, then start a new parentheses, and let's go negative 10 y squared minus 4x squared y. Does everyone see that we have a binomial times a binomial? Two terms in the first parentheses, two terms in the second. The way that we multiply these together is a little different than what we were doing with the monomial. Monomial, we were just distributing it through, weren't we? We were just taking what was on the outside and just multiplying it to each thing on the inside of the parentheses. Here, because we have two sets of parentheses, we're going to do a slightly different tactic. Now watch the way I do this. I'm going to take the first term in the first binomial, and I'm going to multiply it times the first term in the second binomial, which would be this one right here. And I'll draw a little loop going from there to there. I'm going to do that first, all right? Then after I do that, I'm going to take that same first term and multiply it times the second one. So what I'd like for you to do is just imagine, almost if you could, imagine that that second term isn't there, right? In the binomial in the beginning. Imagine that second one's not there. Then if I said multiply, you would have a monomial, right? That monomial would go through and multiply times each of those. That's what we're going to do first, all right? So I'm going to do that, and then I'm going to do this. Okay, what would you get if you multiplied the red one there? Minus 30x y to the third power. Now you may need an extra line to do that, and that's fine, but I'm working a little faster here. Now what would the blue one give us? Negative 12 x to the third y to the second. That's what we would do, right, if we didn't have that second one there. That seems pretty natural. Okay, but we do have the second one there. So now what we do is we say, okay, I've taken care of the first one already, right? Done that already, passed it through, distributed it. So now that I've done the first one, I'm going to come through and now do the second one like it was the only one there and distribute it to both also. That make sense? Okay. So now I'm going to take the second one here, and I'm going to distribute that. So I'll use a black here. I'm going to do my little loops on the bottom instead of on top so I don't cross them. And I'm kind of out of colors here, so let me go to my little palette. Let's see. What'll show up pretty good. Let's see if this light blue works. That's better. Okay, so you do the black one first. What would you get if you do the black little loop there? Negative 40 xy to the third, fourth. Okay. And then negative 16 x cubed y cubed. Now, are any of these like terms? Almost, right? xy cubed, xy to the fourth. That's almost a like term, but it's not, right? Let's see. X cubed y squared, x cubed y, okay, y cubed. I can't put those together, right? So none of those are like terms. So we're done. Now, there's another way of teaching this that I'm sure you may have heard. It's called FOIL. Have y'all heard that before? I'm going to show you something. F-O-I-L, right? FOIL. And FOIL stands for, if you have a binomial and binomial, you do the F is first. So you do the first one here, multiply them together, you get that, right? Then the O stands for outside ones. So you do the outside two, Wasn't that the blue one we did, the dark blue? That was this, right? The outside one? And then the I for inner, so you do the inside ones right here. That was our black multiplication. And then this one right here is what? The last terms. So last and last. It's cute to have a little acronym, but I'm not a big fan of FOIL, and I'll explain to you why when we do the next one, all right? So if you like FOIL, stick with it, but you have to be careful with FOIL, as I'm about to show you, all right? Let's try another one. Not another one. Let's go to the next thing. We'll do try in a minute, but we're going to do binomial and trinomial now. Uh-oh. Binomial and trinomial. So let's go x minus 2y times x squared minus xy plus 4. Does everybody see the binomial and trinomial? Yes? Okay. How many of you are that have heard of FOIL before, like FOIL? You like FOIL? It has to be 2 and 2. Well, with 3 and 3, FOIL doesn't, you don't have a... Yeah. See, the problem that I have with FOIL is that it works with binomial, but when you get to binomial, trinomial, you don't really have FOIL anymore. Because if I do first, outer, inner, last, that's not all the multiplications you really need to do. So instead, I like for students to approach it the way I approached that first one. Right before I showed you FOIL. What I did was I said, look, in the first one, what do we have? The first parentheses, we have a what? Binomial. So if it was a monomial, we would know what to do, right? So if I just act like that other term isn't there, then what would you do with that x? Distribute it through, right? And then after you do that x, you do what? Then you come back and say, okay, I did the x, now I do the -2 and distribute it through. If you do it that way, then you don't need FOIL, and it'll work all the time. So it'll be, we're just going to start with the first one, and we're going to distribute the first term in the binomial through, and then we'll do the second term and distribute it through. Okay? That's going to be the pattern. So my first one, I'm definitely going to run out of colors here. All right, so what's the red? X cubed. What's the green? Negative x squared y. Is that all right? Okay. I'm talking the green one. The green one is the x times this right here. So what we're doing again is imagine we're that doesn't really work. We're acting like that's not there, right? And we're just passing the x through. So what will my next one down here be? Plus 4x. Now what I'd like to do is I'd like to cover up the x. Well, cover up. I'm trying not to go over the negative sign there. Cover up the x. And now I'm going to pass what through, distribute what through? -2y. So multiply -2y through there, and let's see what we get. What's -2y times x squared? -2yx squared, right? Now I could write that x squared y, couldn't I? You can change the order. And normally we try and keep the order consistent, all right? Next, positive 2xy squared. And then what will the last multiplication down here give us? Negative 8y. How many terms do we have right now total? 1, 2, 3, 4, 5, 6. A binomial has how many terms? And a trie has 3. When we multiplied them together, we got 6. 2 times 3 is 6. That's always the case, all right? But do you notice anything on these terms? There's 2 of them that are like. Good. We have the negative x squared y, and we have the negative 2x squared y. Those are like terms, and we can combine them together. Are those the only 2? Yep. So what's negative x squared y take away 2x squared y? Negative 3x squared y. So I'm going to go x cubed. I'll go ahead and put negative 3x squared y. I'll put 4x plus 2xy squared minus 8y. Questions? So that's buy and try. And the last that we'll have today is try and try. Now, let's just kind of take a guess. If you have a trinomial and trinomial multiply them together, how many terms do you think we're going to get? 9 terms. Because 3 and 3 multiplied, we should get 9 terms. That means we're going to have 9 multiplications that we're going to have to do. Let's see how it works out. Go back. Okay now? I forgot to put try. Sorry. Now here, FOIL completely breaks down. Okay, you can't use that. So let's start off kind of like I said. You look at the first term here, and that first term in the first parentheses is going to go through to everything in the other parentheses, right? To all 3. Once we're done with that, we'll move on to the second term, and we'll pass it through. And then we move to the third term and pass it through. So our first pass through here, we should get what? Negative 6x to the 4th plus 14x cubed, and then negative 4x squared. Okay, that's our first multiplication. Now I move to the second term, negative x, and I pass it through to all 3. So we get positive 3x cubed, negative 7x squared, and then positive 2x. Good. And we have one more multiplication to do. It's going to be this 5, and I'm going to pass it through. I'm going to put the little loops on the bottom. Starting to look like a big mess, huh? So what do we get? The first term we'll get is negative 15 x squared plus 35x negative 10. All right, now like terms. Any like terms here? Okay, we have x's and we have a couple x squares. We have a lot of like terms, don't we? So let's start with the negative 6x to the fourth. Are there any other x to the fourths? Okay, so I've done that one, right? Now let me look at x cubes. I have x cubed here, x cubed here. That's the only ones I have, right? So if I do 14 and I add 3, I get how many? 17 x cubed. So I've done those. I kind of cross them out as I go. X squared is negative 4x squared. I have another negative 7x squared, and then I have another negative 15x squared. Negative 4, take away 7. Negative 11, take away 15. Negative 26 x squared. Got the x squareds. Now I've got the 2x and 35x, which is 37x, and then minus 10. There we go. Okay, now I'd like to show you quickly another way of approaching this. It's not something that I like to teach, but I'll show it to you in case you are having trouble with something like this. And some of you may have already seen this. When you have the original problem up there, right, 2x squared minus x plus 5, what you could do is you could write 2x squared minus x plus 5. And then down, like on the side, you can write the other one, negative 3x squared plus 7x minus 2. And you create this table. Has anyone ever seen that, something like that before? And then what you do is you try and figure out what each of these boxes are. So if I want this box, I multiply this one and this one together. So 2 times negative 3 is negative 6, and then x squared and x squared is x to the 4th. You like that table? I'm just showing this to you so you see there's other ways of approaching it. Negative x and negative 3x squared, I multiply negative and negative is positive, right? 3 and then x squared and x is x cubed. So I get 3x cubed. And if you fill out the whole table, negative 15x squared, let's see, 14x cubed minus 7x squared, 35x, negative 4x squared, 2x, negative 10. All right? Yeah. I guarantee you, yeah, well, if you're okay with that, don't worry about it. You're just like, for this one right here, negative 7x squared, what I did was 7x and x together. So this column, this row. Each one of these boxes comes from that column and that row. But if you look at this, we have everything that appears in this table. How many pieces are in this table that we calculated? 9, right? And didn't we say we'd have 9 up here? Every one of these matches somewhere up here. That's your negative 6x to the 4th. 3x cubed, right there. Negative 15x squared, right here. So every one of these appears up here somewhere, right? So in my experience with teaching this, at this level, if this table helps you, fine. But in college algebra, when I see a student and I give them a problem like this in college algebra and they go to a table, I'm a little bit hesitant because the table is kind of a little too basic. Yeah, it's a little, that much visualization that's needed is a little, it means that you don't understand the distribution property here. And that to me is more concerning. But for now, if this helps you get going, then do it. Yes. That'll. Yeah, I mean, if this was a binomial, imagine that's not there. Watch. Imagine that's not there at all, and this isn't here at all. Then that would be a binomial times a binomial, wouldn't it? Binomial, binomial. And so these four would represent. It would do bi and tri would be fine also. If I take this away, there's a bi and tri. This is bi, this is tri. So it'd be these six. Make sense? And I mean, this you could go 8 terms times 10 terms, and then you just add like terms together at the end. I'm not discouraging you from using the table. If it makes you better at this, then go for it. Okay? All right. Now, move along. I want to look at another problem. What about this? What does squaring something mean? Multiplying it times itself, right? Remember, x squared meant x times x. So if I say everything in that parentheses squared, I mean everything in that parentheses times everything in that parentheses again, right? So it looks like this. Times itself. And that's a what times a what? Binomial and binomial. So I can go and start with the negative 4x, pass it through. Then I can go with the 3 and pass it through after I do that, right? Let's see if we can write that out real quick. What would it be? 16 x squared minus 12x, right? What's the inside multiplication? 3 negative 4x would be negative 12x again, right? And then what's 3 and 3? 9. Man, my computer's really acting weird. Any like terms? The middle two? 16x squared minus 24x, then plus 9. You see that? Okay. What is the big mistake I see with this? Wrong. What is the thing I see a lot? Students will see the squared, and they try and just square each one of those. So they say, oh, okay, I'm going to square negative 4x, which is 16x squared. And then they say, oh, I'm going to square 3, which is positive 9, so they put plus 9. Oops, I forgot my squared on the 16. And they say that's the answer, right? You see, squaring the negative 4x and then squaring the 3. Well, this is almost the answer, isn't it? Almost. This is it. There's your 16x squared, there's your 9, but there's a middle term that's not accounted for here. This is completely wrong. And on a test, if you do that, you won't get any credit on the problem. 0 points. No, I'll just put that right there, just the way it appears right there. So you have to know that this means this, that times self. If you do this, no credit, 0 points. It's not even like, almost. That's like a huge, huge mistake. I see it a lot from students throughout college algebra. So just be careful. Now, when can you put the 2 in there? When can you do that? If it doesn't have addition inside. Remember if we had this. If I had this squared, what's the operation? What are the operations inside the parentheses? Multiplication, multiplication, right? In this case, yes, you just square the 4, you square the x squared, and you square the y. That I agree with, if there's multiplication in here. If there is addition or subtraction like we have up here, that is not going to work. So be real careful with that. All right. Let me put your homework here. think I'm going to let you go a little early today. I was going to have you do a bunch of work in class. We have 15 minutes. Y'all want to go early or y'all want to stay and do work? It really doesn't matter to me. If you want to do work, you can come down, to my office. I'm going to be in my office, but I've been feeling kind of weird today. No. I think it's allergies, but no, I woke up, I felt like I got hit by a truck, but I'm feeling better now. So I don't know what's going on. Oh, sign in. Yeah. Thank you. Where is it? Oh, also, when I pass this around, you'll notice that for today's date, if there's a number in there, that number is how many absences you have so far. And if it's a 3, then I put a little pink line through it, and that's just to let you know you have 3 absences right now. 1 more absence is all you get. So just a reminder to you. So just if that's you, just initial over it. That way, I want you to see it and initial it so you know what's up. All right? Okay, so for homework tonight, what I'd like for you to do is number 7, 11, 15. This is page 368. 19, 23. Those are all, well, like monomial or monomial binomial. Then we start getting some more advanced ones later. So here's some of the more advanced ones. 27 has fractions in it. 31, 39, 47, 55, 59. This seems like a lot, doesn't it? I'll give you one trinomial, 63. And I have one more problem, or 2 more problems, sorry for you to do. These come off of page 376. Number 39, number 41. These last 2 are like the one I just did where it was something squared, and so, you have to make sure you split them up. That's quite a bit of work. See how you get through that. Be ready on Thursday. I have a conference this weekend that I'm going to in Austin, and so on Friday I won't be here. Just so you know, no, I don't think anyone's ever come to my office on Fridays for office hours, but just so you know, I'm not going to be here Friday, all right?